Okay, now either border blurry, unblurry, or something, but let's see if we can get the camera to focus. Okay, so as I said, we need to be able to do these perfectly, and I'm saying something that looks close to right, but it isn't. Okay, and it's going to result in bad estimates. So let's make sure we understand what to do. Now, this looks like a pretty good square. When I look at it from this angle, when I look at it on the screen, I think it's lopsided. Okay, well, try to make it as accurate as you can when you do the big one that I asked you to do, okay? A lot of you are moving along with that. Okay, so for the squaring function, what? I'm just going to do this really fast. Divide it in half. Take each rectangle, divide it in half. And then each of the rectangles is next to the center line, we divide those in half. Then we divide it in half horizontally. And then we divide the lower rectangle in half. And we divide the lower rectangle from that in half. And we divide the lower rectangle from that in half. So let's see. Okay. So I think that's about it. Does that look right? I mean, if I didn't do it right, because it's got to be perfect. Except for the relative artistic ability. Okay, and now we mark the points. Start up here, move over one, skip one, skip one. Keep over one, skip one, skip one. If you don't know what I mean by that, go back and look at the video or look at the videos that I posted, okay? Video from class, videos that I posted. We've got the red dot down here. Remember, the red dot's important. Next time I'll probably ask you to indicate where the red dot is on each graph, okay? Anyhow, then we go symmetric. So symmetric with this one is this one, symmetric with this one is this one, symmetric with this one is this one. Now, y'all are pretty good with symmetry, but sometimes I'll see a graph that goes through this line here, this horizontal line here, not here. Okay, I've seen that. I've seen graphs that don't go through this point, they go through this point. You got to know the algorithm and you got to know it exactly. And everything in this course you want to know as exactly as you can. So when you did the videos, when you constructed these, if you weren't totally clear on what the rule is for each one, when you had access to all the materials and everything, well, you missed stuff and try to learn not to miss it, okay? And there's a saturation point, but nobody was saturated when we did this in class. And all I'm saying is, somebody didn't prepare well enough. It wasn't bad, but it wasn't good enough. Okay, it's got to be good enough. It's not good enough to build on. It's not good enough to make the estimates that we're going to make. And that's kind of one of the big points of the class today. Okay, you're going to get bad estimates. When you do a big graph, do it well and do it right. This is the one we're going to talk about today. We'll talk about the others too. Make sense? This is achievable. Everybody can do this. All you have to do is practice enough. That's what I mean about preparation. Okay? Get in the habit of really preparing. Okay, well, anyhow, as I said, what I see isn't bad. It's just not good enough. Got to be good enough. There we have a curve. All right, well, let me just quickly draw the other two. Do the exponential here. With the exponential, remember, you divide it once here, you divide it once here, and you divide it once here. So that all these lines are more or less equally spaced, as close to equal as you can make them, because ideally they're equal. Okay. And then we line it off horizontally, the same as we did the squaring graph, because we need all the same lines. Now, where do you start? I see a lot of graphs that start here in the lower corner. If you were paying attention, taking notes, and making sure everything was precise, you would know that it starts on this lowest dotted line, not on the lower edge if it starts in the lower edge, you're done for. You will not get a good graph. You will not make good estimates if it gets to that, okay? And you won't understand what you need to understand about the function. So I'm being very clear that I want everything correct. Again, you're in a position where you can do that. As best you can, make sure you've got it all right when you come into class. Okay, get in that habit. Now the rule is simple: over one, up one, over one, up one, over one, up one, over one, up one. There you got the points. But you got to start in the right place. If you start down here, you can't do it. The rule won't work. And the graph won't be right. Okay, well, I don't have room over there, so we'll come over here. Now this one is probably the most challenging. And it's the one where I saw a lot of things that were kind of off the wall. I saw some that were really good, but the goal is do it right. And remember for the rest of your life, at least for the rest of your mathematics career, how to do it right, because these graphs can be very useful to you. Okay. So we divide this one just the same as we did. Actually, yeah. That was a little too low. I'll go with it. In other words, vertically, we divide it by the same rule we use for this one. Horizontally, we divide it by the same rule we use for this one. So that it's symmetric. If it was rotated 90 degrees, it'd still look the same if it was done exactly. Okay. Then where do we start? So put people starting on the center horizontal line. You got to know where to start or you're done for. Okay. You're not going to get good estimates. You're not going to get good results. Your whole business is going to collapse. Western civilization is going to go down the tubes. All kinds of terrible things are going to happen. Well, that's an exaggeration. But bad things will happen in this course if you don't understand this. Maybe not terrible things. Maybe you can take your way around some of it, but right there it is. Okay. This point, the point on the line at the left edge, immediately below the horizontal center line. Then the red dot goes in the middle here. Move over here symmetrically with respect to this. And then you have some more symmetry, and you're going to have these points. And then you're going to have this point here. So what you're doing is you're moving one horizontal line over. Sorry, one vertical line over, moving horizontally, but you move one vertical line over and one horizontal line down. Once you have the first point, you can do that. Okay. Here, you move over one, up one, over one, up one. That's what I said. And that's pretty much what you see in all the materials. Okay. Okay. So there are our graphs. Now, again, I saw graphs that didn't go through this point. I saw graphs that started here. I saw graphs that just kind of went down here. They had the right shape, but they weren't in the right place. That right shape is important. I respect that. That's a good thing. But it's got to be right. Okay, I've got it. And you're working on your own paper, but put your name there, someplace where you're unlikely to have it covered with your hand as you're working. Now, if you're right-handed, upper left-hand corner would be a good place. In the lower, somewhere on the left, so your right hand doesn't cover it. If you're left-handed, somewhere on the right, wherever you think your hand is going to be when I look, because then I can see more as I go around. Write it kind of dark, so I don't have to strain to see it. Light can be funny in this room. And and as clearly as possible. I will give everybody full credit on this. Okay. But next is going to be strict. You make more accurate. We're going to do some estimates. Figure the graphics. You got time to make it, baby. Okay, let me show you. First place, if you got a big graph of the square. Okay, you want to get that? Let me look at what you're doing. Here. Okay, that's good. That's good. And that's good. These points are a little close together. You know, this should divide this rectangle in half, and it's a little over this way, so it'd be more accurate if you make it big. Be sure you're dividing the rectangle in half. But you have the right points. So now here you don't, because it should have been this point here, not this one. Okay, you can't have one directly below the other. There's your red dot, that's good. So except for that point, it's technically correct. Be really careful about the halfway thing. So since you're doing that, go on and make yourself a big graph of the square section. That looks really good. Okay. Make you look good. Okay. You do. Where's your big graph of the square? Good. Yep. Good. I think you divided the wrong direction. The one choice. So we grab this. You have to look carefully. Remember how. You do. Estimates and that, but they're not going to get. You're not going to get good results. Tells you why. Okay. Well, where's your big graph? Big graph of the slope. Big graph takes up as much as you can live with that. Okay. Graph, I really mean like the big labs, the biggest graph you do. Okay. If you got time, go ahead. If not, you can go with one. That's just. You're trying to compete with NASA for correctness, you're going to be at a disadvantage. Big graph. Okay. Okay. Now, if you don't have a big graph, you're going to have to go with a little graph. I don't have a big graph, so you got another minute or two. Probably 5 or 6 before I find my chalk. I'm going to put it this. Huh? No, that's, yeah, I want that. Yeah, I can have thought that. Wasn't the pitch. Now you'll notice when I divided this rectangle in half, I was over too far this way, wasn't I? And you'll notice when I divided this one in half, I was too far over this way again. So my graph isn't going to be great. Hopefully yours is better. It took me like 20 seconds to do this one, okay? And it isn't too bad. If I'd have taken a minute, it would have been better. You don't want to take 10 minutes to do these graphs. You want to be able to draw them quickly. And depending on what you're doing, maybe more quickly or less quickly. Okay. So anyhow, you got your points. Now, I'm going to put dimensions on this. Okay. It's going to be 4 units here. And 4 units here. So 4 by 4 square. Yet from this point to this point, how far should I move to the right and how far should I move up? Don't do the. Okay, so once again, these are the first numbers we've seen in the course. Okay, everything is construction. Once you've constructed it, you can start putting numbers on it. We put it on an XY coordinate system with the red dot at the origin. And you understand what that is. Okay. And then if we want to get from this point to this point, how far do we have to go? Well, this is 4 units. This is in the middle. So this from here to here is 2, and everybody knew that. Okay. So then you have to do the reason. It was obvious. And then we've got to go 4 units here. Everybody understands that. And I think everybody understands why the coordinates of this point are therefore 2, 4. First coordinates, how far we got to go from the origin in the horizontal direction. Second is how far we got to go in the vertical direction. All right, well, you know that. Now, one reason I started with construction is, first place, I want you to learn to do things precisely, and that's very achievable. There's no algebra, there's no arithmetic. You don't have to take a negative power of a number as you would if you're trying to do the exponential function from the algebraic definition, okay? I haven't told you what the algebraic definition of this one is. You might know, a lot of you probably do. Another thing is, you know, the world was there before algebra was. Okay. And things that were more or less square have been around for, billions of years. A lot of times at the subatomic level, but fissures in the earth could be more or less square. So the idea of defining functions by their algebraic expression hadn't been around long. The world was there before that. Okay. And things were dividing themselves up before that. So just that's kind of a philosophical thing. I'm not going to go too far with that. But I want you to understand these functions. The reason we're doing this, I want you to understand these functions in the most tangible possible way, and doing arithmetic and algebra, you might in some cases be a little fuzzy on, isn't the way to start. Okay, as I said last time, we want to ease the end of the algebra. Now we're going to do just a little bit of it today. But, so here we are. Okay, so for the first time, we're putting numbers in this thing. There it is. And this is a graph, if you know precisely what to do, that you can really understand. All right, so let's see. How far would you have to go and how far up on this? Don't tell me. Put it on your paper. And then this point, this point, this point, and this point. A couple of them are a little bit tricky, but just kind of write that on your graph. See if you can write down the coordinates. Everybody gets it right. I won't have to explain it, but there's something that I kind of expect people will tend to sometimes miss. Okay, now I haven't looked at everybody's paper. I haven't given everybody time to reason all this out. People are doing okay with it for the most part. Let's look at something. On this middle line, the vertical middle line, what is the x coordinate? Show me with your fingers. Don't say it because recording is on. Okay, you use that for 0, or you can use that for 0, or you can use that for 0 if you really want to. Yeah, somehow you can indicate 0. Okay, now you probably know how to indicate 1. Use the right finger in the right direction. Okay, whatever. And 2, can you do 2? Yeah, you can do that. Okay, probably handle 3, and some of you are probably able to handle 4. Well, yeah, everybody can do that. Okay, what if you want to do 1/2? Okay, here's a gesture for 1/2. Okay, just like a slab, and there's a numerator, so understood to be 1. So that's a half. I'm going to learn all kinds of sign language. Okay, so tell me, what's the x coordinate on this line? Does it change from point to point? No. The x coordinate of every point on this line is 0. If I label any point on this line, this point would be 0 something. This point would be 0, 4, because we don't have to go right or left. We don't have to move horizontally. I want to make sure you understand it that way, not just out of memory, but understand it because that's the way it has to be. If we define the coordinates as how far you go horizontally and how far you go vertically, everything becomes obvious. Also, that whole thing of moving horizontally, moving vertically is really important in this course. You want to emphasize it. All right. So let's see, what about on this right edge? What's the x coordinate? Show me. Yeah, you got to move over 2 to get to that thing, right? So let's see, we're going to say that I'm going to erase this thing because I really need to label system. That's the is coming into play. So you had a lot of affection for it. I apologize. I'll go away for now. Okay. Oh, I'll use purple. I'm going to do this. X equals 2. That's this purple line. Okay. So what's this purple line? See if you can invent a sign language that tells me what that is. Yeah. Okay, -2. Everybody knows that, and if they didn't, it should be clear. Okay. So go ahead and extend each of these vertical lines and tell me what X is on each vertical line. Just label it the way I have. Just give it, here's X equals 0. Here's X equals something. Here's X equals something. So, yeah, maybe we don't have room to label this class. So here's X equals something, and here's X equals something. Okay, whatever way you can make it clear, show me what X is. And then for each horizontal line, tell me what Y is. Okay, please don't talk now. Conversation when the recording is on, it is on. So. Okay, so this horizontal, well, let's start with this one. What's common on this one? For every point on this line, you've got an O of 4 units, right? So Y equals 4. On this line, if it's really in the center, I think it's a little high, but you're going to have Y equals 2. That's the distance from 0 to 4.5. Here's Y equals 1. Now what about here? Oh, Y equals 1/2. And here Y equals 1/4. Because of course, if this is 1 and you cut it in half, you got a half. Okay. If you cut a half in half, you've got a fourth. It takes 4 of these to make this. So that's exactly what it means. Okay, there you got it. Now, it should be easy to accurately label all your points. And most of you have done that. But there's been little bits of confusion here and there. I'm just trying to find a good color, contrast with everything else. Well, I want to use that. That doesn't contrast much with the green that we'll use. Okay, so this point is 2, 4. What's this point? It's where the X equals, and I just like these, but okay. It's where the X equals 1 line meets the Y equals 1 line. So this point is 1, 1. What 2 lines meet here? The X equals 1/2 line and the Y equals 1/4 line. So the coordinates at this point are 1/2, 1/4. Then similarly, this is the X equals -1/2 line, and this is the Y equals 1/4 line. So that's -1/2, 1/4. Of course, the dotted line deserves to be labeled. It's going to be upset if all the other lines. I'm sorry, the red dot is at the point 0, 0, and then we have the point -1, 1, and there are the points. Okay. Okay, now, most of you got these right. Okay, but there were several of you got part of them right. Maybe you didn't know how to square 1/5. And maybe you're not sure how to square a negative number. Maybe you're not even sure what a square is. Okay. How do you square -3? What's the square of a number? Well, -3 squared is -3 multiplied by -3. You multiply -3 by -3, you got 2 negatives, you get a positive, and 3 times 3 is 9. Now, I haven't seen, maybe it's very, very few negative numbers over here, but a lot of times I'll get like a -9. see the negative sign, you careless and so forth. You don't think about what it means. That goes along with my admonition to think precisely. Don't just slop something down. Make sure you understand why you're doing it to the extent that's possible. Okay? So it would be good, and I'm going to actually probably require that when you're making a table, you write out the calculation explicitly, not just -3 quantity squared equals 9, -3 times -3, okay, equals 9. And that's a general principle until we're sure that you're sure that you're not going to make careless mistakes. You want to write it out explicitly. It takes a little more time to do that, but you reinforce it, and pretty soon you're moving faster than you would have before, and you more than make up that time. Okay, so here, -2 times -2 equals 4. With 1/5, let me write out that 1/5 times 1/5. Well, how do you multiply fractions? You multiply the numerators and multiply the denominators. How do you add fractions? You don't add the numerators and add the denominators. 30% of a typical pre-calculus class doesn't understand that difference because they haven't learned to think mathematically precisely. They haven't been careful enough. They haven't been precise enough in their thinking. Okay, everybody's capable of doing it, but a lot of people don't bother. Be one of the people that bothers, because everything you do in life is going to be better, not just your mathematics. Okay, 1/5 times 1/5 is 1 over 1 times 1 over 5 times 5, which is 1 over 25. If you bypass this calculation by using your calculator, you don't learn anything. You don't reinforce anything. Now, if it was 1 over 738 times 1 over 738, I would expect you to use a calculator. As a matter of fact, if you don't, I'd probably refer you to mental health services. Okay, well, not really, but I'd admire your ambition, but question your judgment. Okay, make sense? Very important. Get it precise. Don't screw it up. Know the rules and apply them, and write it out in a way that reinforces the rules, because I've seen it exhibited year after year. A little better this year than it was last year. Maybe we're getting over the COVID dip. Okay. So that's encouraging. But still, there's an epidemic of sloppy thinking. Not just in mathematics, and I'll just address the mathematics. Okay. Can you use your graph to figure out the value of x is if y equals 3? What I mean is the graph point where y equals 3, what's the x coordinate? Okay, as I just said, people did pretty well with this. We'll lock it in. I waited until I saw somebody actually doing it, but we can draw the line y equals 3. We don't need it to construct the graph. It wouldn't do us any good. Okay, because you can't even write out in decimal form the exact number for y on the graph. But we can locate the y equals 3 line. So the y equals 3 line will go halfway between y equals 2 and y equals 4. Now my graph isn't great here, so I'm not going to get a really good estimate. But there it is. And I said, what points on the graph have y equal to 3? And the answer is, I thought I had. Well, this point and this point here. Now those points should be symmetric with respect to the y-axis, shouldn't they? Okay, they're pretty close, but from here to here is a little less than from here. This is a little further than this. It's a little, either this is a little too close to this edge, or this is a little too far from this edge, or they're both screwed up some other way. But they're not badly screwed up. They're pretty symmetric. So I'm expecting I'm going to get a fairly good estimate. Now, how do we get the x coordinate? Well, to get to this point, we start here. How far do we have to go over? Well, we go over until this point is directly below this one, right? Okay. Well, it would then help to draw the line that at least goes from this point down to here. Okay. We have this, and we do the same thing over here. There are two answers to this question. But right here is an x. You can see this in the x-axis. Can you see where 1 is? You can see where 2 is. Is it closer to 1 or 2? Show me with your fingers. Clearly closer to 2. Okay. Now we could just as an A, we can take this interval and then come in. Okay, that looks like about half the way. That's about 1.5. Do the same thing over here, and 1.5 go about here. It's about symmetric, a little bit off. And of course, my vertical isn't necessarily exactly vertical, but I make a pretty good vertical line. And now I know that my x value is between what? What's x here? You show with your fingers? Well, x is 1 here. It's between 1 and 2, right? So you're going to have to do 1 in some fraction. Yeah, 1 and 1/2. Okay. Now, x is about 1.5 here. Now, at this point, when you're making estimates, the decimals start to make sense. Okay. When you're labeling these points, you can label them accurately with fractions, and I prefer that. I think you learn better and you relate to fractions more easily if you get in the habit of doing that. Okay, but here x is, we'll say 1.5. Okay. So 1.5, you could do 1. Okay, 1.5. Okay. Okay, well, if this is I did it wrong. 1.5 by 1.5. Okay, can't see that. What do you think this is? Show me with your fingers. That's good. Okay. Now I've seen a 1.75, and I think it was 1.74, wasn't it? Now, don't worry about it if it wasn't. You still have the glory of having said that, whether you really did or not. Yeah, you were good. Okay. Looks to me like about 1.7. 1.75, I think it's a little closer to this point than it is to this. If it was halfway between here, well, halfway between 1.5 and 2 is 1.75, right? We're just looking at it to the nearest tenth. It looks like it's closer to 1.5 than it is to 2, and you're kind of stuck with 1.7. Okay? And over here, it still looks like about 1.7. Maybe a little less, but it's negative. Oh, that makes sense? That's how you answer a question like this. Well, you just solved an equation, approximately. You didn't know you were solving an equation, did you? Very simple equation. Equation is first of all, your function is y equals x squared. Your question was, if y equals 3, what is x? That was the question, right? Which is why I posed it. What is x if y equals 3? Of course, I did the equation in reverse order, but you know what I mean. We just constructed our y equals 3 line. We figured out what the x coordinate is, and we got 1.7. Now, that's not exact. You ask your calculator to solve that equation. Very easy. Your calculator is going to give you about 1.732 down to a bunch of numbers that long. That's not right either. It's much closer. It's not right because it goes on forever. It's an irrational number, never stops. Okay? So there's no exact solution that you can write up. Well, there's an exact solution, but you can't write it out. Okay, if y equals 3, what is x? Well, if y is 3, then you're going to write 3 equals x squared. That's a no-brainer, isn't it? It's not an equation that comes down from the clouds or whatever. It's exactly what that means. Okay. Now, usually we want to write this in the reverse order because we want our x to be on the left. So we have x squared equals 3. Now, can you tell me how have you been taught to solve that equation? Whoops, almost did the wrong thing. Never made a mistake before, but I don't want to start now. Okay. Okay, now a lot of people are writing down something that's right for this one. Okay, but there are 2 solutions. And there's a symmetry. Okay. So a lot of people have written down the correct solution. Not everybody. Some people have trouble figuring this out. And we'll do that in a minute because we've got all of 3 minutes left. Okay. How do you write down the second solution? Well, we've only got 3 minutes left. I'm going to give you a minute to think about it. And I'm going to look a little more, and then we'll finish it. Okay, so we have x squared equals 3. Well, the solution that I've seen is x equals the square root of 3. Okay. Well, that's right. That is this. So we're going to say here, our approximation is x equals 1.7. Well, the square root of 3 is 1.732 and then some stuff. So that was good. And if you said 1.75, you were actually closer than 1 to the right solution than 1.7. That was 1.7. So, you know, that was an equally good estimate. But okay, we got x equals 0.3, which is approximately equal to 1.732. And if you want to see the rest of the numbers, use your calculator. The graph shows 2 solutions. Well, oh, dang. Now there's negative square root of 3. Now you got a rule that says when you do this, you put a plus or minus in front of your square root. You don't understand that rule. That's just a rule. I would bet that 1 person in 50 who comes into pre-calculus class knows why that rule is what it is in a way that connects with the graph. You do. Okay. So you want to show off, just go around on this graph and pull people off the street, making them, yeah, impressive. I don't know, don't do that. Okay. Meaning of an equation, meaning of the entire graph. Reason for that plus or minus, it's right there on the picture. Okay, well, I'll post to the assignments page. I'll be fairly lenient on you as far as the workload. You can need to do a day's work between now and then, but you don't need to do 2 days work because it's Labor Day weekend. Okay? You can do that before or after Labor Day weekend. Get it done. Let me